Good afternoon, class. This is our first video lecture on engineering mechanics 2, and our first topic is kinematics of particles. So kinematic relationships are used to help us understand and to determine the trajectory of a golf ball, the orbital speed of the satellite, this one, and the accelerations during acrobatic flying. So there are many instances where kinematics is used to analyze certain problems. So for our introduction, there are two types of mechanics of materials, the statics and dynamics. And this is the second part, dynamics. It includes kinematics and kinetics. So kinematics is the study of geometry of motion. It relates displacement, velocity, acceleration, and time without reference to the cause of motion. While kinetics, on the other hand, is the study of relations existing between the forces acting on a body and the mass of the body and the motion of the body. So, kinetics is used to predict the motion caused by given forces or to determine the forces required to produce a given motion. So there are um, two types of motion in kinetics. So the rectilinear motion and the curvilinear motion. In the rectilinear motion, positions, velocity, and acceleration of a particle as it moves along a straight line. So the analysis of the train, as you can see in this photo, is a rectilinear motion. While curvilinear motion is the position, velocity, and acceleration of a particle as it moves along a curved line in 2 or 3 dimensions. So, important points to consider. I have taken these notes in our textbook. So, dynamics is concerned with bodies that have accelerated motion. It has two branches, kinematics and kinetics. Kinematics is a study of geometry of motion, while kinetics is a study of the forces that cause the motion. Rectilinear kinematics refers to the straight line motion, while curvilinear kinematics refers to the curved line motion. So speed refers to the magnitude of the velocity, while average speed is the total distance traveled divided by the total time. So average speed is different from the average velocity, which is the displacement divided by the time. A particle is slowing down. A particle that is slowing down is decelerating, while a particle that can have an acceleration and yet have zero velocity. So the relationship AdS is equals to VdV is derived from A is equals to dV over dt and V is equals to ds over dt by eliminating dt. Okay, before we proceed, let's define first these terms so that you can understand it better. So, as I said earlier, rectilinear kinematics is characterized by specifying the particle's position, velocity, acceleration at a given period of time, at a given instant. So, for the position is defined as S. From your origin, 0. So, other books are using X, so don't be confused with S or X. In our textbook, it uses S. So, in this figure, the origin O, the path is fixed in this point, and the position coordinate S here is used to specify the location of a particle of this particular point. The magnitude S is the distance from your origin, O, to the position of your particle. Usually, this is measured in meters, in feet, in kilometers. So the sense of the direction is defined by the algebraic sign on S. So our convention states that going to the right, it's positive. To the left, it's negative. So the magnitude, the algebraic sign of S is positive. Although this is just arbitrary, pasabot, it's our convention. Others maybe are using to the left negative, to the right positive. In this case, S is positive since the coordinate axis is positive to the right of the origin. Likewise, it is negative kung to the left siya. However, it is being represented by the algebraic scalar S since the direction always remains along the coordinate axis. Displacement. Displacement of a particle is defined as delta S. So delta S is defined as S prime minus S. S prime is your final position while your S is your initial position. By definition, displacement of a particle is defined as the change in its position. So if this example, this particle moves from from point S to point S prime, then its displacement is delta S. From here to here, from S to S prime. So ang iyang displacement is delta S. As I said, the sign of delta S is likewise positive since it's the final position is greater than the initial position. S prime is greater than S, so that is why it's positive. And if the final position, if it happens that the final position S prime is between here, then delta S is negative. The displacement of a particle is also a vector quantity, and it should be distinguished from the distance of a particle travels. Specifically, the distance traveled is a positive scalar that represents the total length of the path which the particle travels. Definition of velocity. So basically, velocity is defined as delta S over delta time. It is the displacement, delta S, during the time interval, delta t. So the average velocity of a particle is equivalent to delta S over delta t. And if we approach, and if we take smaller values of t, and we have our instantaneous velocity defined as v is equals to ds over dt. Take note of this, class. This is one of the basic equations used all throughout this book. V is equals to ds dt. Since our assumption is to the right positive, then we have our sign convention here. Then for our acceleration, so it provide velocity of particle. It provided that the velocity of the particle is known at 2 points, at point 1 and point 2. The average acceleration of a particle during that time interval delta t is defined as change in delta v over delta t. Change in velocity from point 1 to point 2 over the time interval t. So delta v represents difference in the velocity during the time interval delta t. So delta v is equals to v prime over prime. Final velocity minus initial velocity. So the instantaneous acceleration at time t is a vector that is found by taking smaller and smaller values of delta t. So a is equals to dv over dt. Before we have v is equals to ds over dt, and our acceleration is dv over dt. Take note of those equations. And if we substitute the previous equation into this equation, we have now acceleration is equals to d2s over dt squared. D squared s over dt squared. So if we manipulate and um, find a in terms of s and v, we now have a is equals ads is equals to v dv. These three equations are very common in dynamics, and you should memorize this one. If not, then you know how to derive these equations. This equation is derived from equations v is equals to ds over dt and a is equals to dv over dt. Just eliminate the differential dt in the two equations. This is interesting. In these three equations, in the following three equations, we consider acceleration to be constant. So use only when you know and you are sure that acceleration is constant. Velocity as a function of time. So v is equals to v sub o plus act. Then position as a function of time, we have s is equals to s sub o plus v sub o times t plus 1/2 at squared. Then velocity as a function of position, we have v squared is equals to v sub o squared plus 2ac times s minus s sub o. Take note, all three equations should have a constant acceleration. So you cannot use the equations if the acceleration is not constant, or if you're not sure that the acceleration is constant, do not use the equation. Stick to the three equations earlier. V ds is equal to dt, v is equal to ds over dt, a is equal to dv over dt, and ads is equal to v dv. So procedure for analysis. Before anything else, before you try to solve problems, I want you to prepare your calculator, your ball pen, your notebook, and your paper for solutions, because every now and then you will ask to solve problems and screenshot your solution to be submitted after our discussions. Okay, some tips for analysis. So in our coordinate system, we have our usually, diba, our definitions of coordinate are x and y axis, Cartesian coordinate system. In dynamics, you can simply use s, to the right positive, to the left negative, if that is your preference, or you can just simply use x like the other books. So first tip, establish a position coordinate s along the path and specify its fixed origin and positive direction. So as I said, you have to fix your origin and label it with O, and to the right positive, or to the left negative, then upward positive, downward negative. Second, since motion is along a straight line, it's rectilinear motion, the vector quantities position, velocity, and acceleration can be represented as algebraic scalars. So for analytical work, the sense of s, v, and a, position, velocity, and acceleration is then defined by their algebraic signs. Third, the positive sense of each of these scalars can be indicated by an arrow shown alongside each kinematic equation as it is applied. So it is always shown in our textbook. kinematic equation. So, these are the three equations I mentioned earlier that you should at least be familiarized with or memorize, better yet, so that all you need to do is to write it every time you need it. If a relation is known between the any of the four variables, acceleration, velocity, displacement, or position, and time, then a third variable can be obtained by using one of the kinematic equations. First, A is equals to dv dt. Second, V is equals to Vs ds dt. And lastly, ADS is equals to VDV, since each equation relates all three variables. And second tip about kinematic equation. Whenever integration is performed, it is important that the position and velocity to be known at a given instant para magamit nimo siya pag-evaluate nimo sa imuhang integral. Third, remember that um, equations katong sa constant acceleration, V is equals to V sub O plus ACT, or S is equals to S sub O plus V sub O times T plus 1 half AT squared, and V squared is equals to VO squared plus 2A times S minus S sub O. These equations are limited of use. It only means that you can only use these equations when the acceleration is constant and when the initial conditions are S is equal to F sub 0 and V is equal to V sub 0 when your time is equal to 0. Okay, for our first example, we will consider this car. It moves in a straight line such that for the first short time, its velocity is defined by an equation V is equals to 3x squared 3t squared plus 2t in feet per second, where your t is in seconds. Determine the position and acceleration of your car when the time is 3 seconds. So, it is assumed that when t is equal to 0, your car is at the origin. Your s is equal to 0. The first thing you need to do is to establish your coordinate system. And by establishing, you have to draw a straight line where your car is going. So, this is the origin and your car is going to the right and it's an positive direction. So, at time t, the question is, find your position s and your acceleration when t is equal to 3 seconds. So you have given the equation of velocity in terms of t. V is equals to 3t squared plus 2t in feet per second. So we already have established, class, get your calculator and paper. Of course, your ballpen pod. It would be better for your sake to though it's an example but still you have to solve it, you have to write it down and solve it using your own calculator para mas masabdan siya kung buhaton dili lang siya tan-awon. Okay, so since our v is a function of t, the car's position can be determined from V is equals to ds over dt. Since this equation relates V, your velocity, your position, and the time t. So, remember that our assumption is when time is equal to 0, the position is at the original position at origin. So, pasabot S is equal to 0. So, V is equals to ds over dt. V is equals to 3t squared plus 2t. So if we integrate ds, transpose this v is equals to v dt, this comes ds is equals to v dt. So integrate as from 0 to s and from 0 to t. So you have your equation s is equals to t cubed plus t squared. This equation. After evaluating this equation, we have s is equals to t cubed plus t squared. So just substitute the value when t is equal to 0, find the s, find the position, and you have 36 feet. So at time is equal to 3 seconds, your car is already 36 feet away from the origin. So from here, 36 feet na siya at t is equals to 3 seconds. Now, let's find the acceleration. Since, of course, the given is v as a function of time, the acceleration is determined from a is equals to dv over dt. Since the equation, we have acceleration, we have velocity, and time. So, now let's derive the equation. From this equation, a is equals to dv over dt, we can get a dv over dt, and we have a formula or a function of v, which is 3t squared plus 2t. So let's derive this equation. We now have a is equals to 6t plus 2. Diba? Simple derivatives naman ni siya. Basic na kayo ni siya nga derivative atong gi-perform. So, for those students who are afraid of integral and differential calculus, please don't be. Kay in dynamics, it's simple or kay nga mga derivatives to kinanglan. No complications. Basic ra ni siya. So, substitution na dayon ta, di ba? When t is equals to 3, their acceleration is 20 feet per second squared. As you can see, it is not stated in the problem that we have constant acceleration all throughout the time. So we cannot use those equations nga using constant acceleration. Okay. Our second example is having a constant acceleration. So this is a rocket, a test rocket. So during a test rocket travels upward at 75 meter per second. So it is its velocity VA. And when it reaches 40 meters from the ground, when it reaches this point, the engine fails. Determine the maximum height SB reached by the rocket and its speed just before it hits the ground. So the find the speed before it hits the ground. So when in motion, the rocket is subjected to a constant downward acceleration of 9.81 meter per second squared. Gravitational ni siya nga force due to gravity. So neglect the effort of the air resistance. Because solution, the first thing to do is to establish your coordinate system. So if this is our origin and our sign convention tells us that going up, positive, going down, negative. So if this is your origin point O, then going up is your rocket. And at certain S sub A is equals to 40, it stops. The engine fails. So to get using the constant acceleration formulas, we have three, di ba? First is V is equals to V sub O plus ACT. Second, we have S is equals to S sub O plus V OT plus 1 half AT squared. Then our next equation is V squared is equals to V sub O squared plus 2AC times S minus S sub O. So, naatay given nga SA or S sub O is equal to 0 or SA is 40. Then, our initial velocity, V sub A is 75 meter per second. Our V sub, wait, okay, so it's establish our coordinate system. Then we have our point. Let's consider this as point A, point B, and point C. So our first S sub A is 40. But we don't know yet our S sub B. And S sub B is our maximum height. Yes. And it's next is since the rock is traveling upward, VA, our velocity at point A is 75 meter per second when time is equals to T. At the maximum height, S is equals to SB, the velocity is 0 because technically it's 0. But the acceleration is, constant, 9.81. Uh, it's negative because it's downward, opposite sense to our positive na velocity going up. So going down man siya, then that's negative. Since acceleration is constant, the rocket position may be related to its velocity at 2 points. So from point A here to point B. So using our third equation, we have V squared is equals to V sub 0 squared plus 2AC times S minus S sub 0, or our second position minus initial position. Since at B, we know that our velocity B is 0 and our velocity A is 75 meter per second, then we get 2 times 9.81 times SB unknown, and our SA is 40. But before, gikan diri padulong diri, actually it's 75, but at this point beyond, since nag-stop ang engine mo nang wala na takabalo until such time nga maximum niya is 0 ang iyang velocity, maximum height 0 velocity. So solving this equation and using your calculator, you can automatically input this equation and you will get an answer. SB is equals to 327 meter. Now, nagamit na ito isa ka equation nga V squared is equals to V 0 squared plus 2AC times S minus S0. Let's use known ang atuang but this equation can also be used to find the velocity at point C just before it dropped or just before it reached the ground. So So kung kani atong gi-first consider v sub o, then kani ang sa ikaduha, this time, let's consider this as our first velocity and our second velocity. And just substitute it into the equation. So, v sub c squared final velocity is equals to initial velocity squared plus 2ac times position sc is equal to, asa ba itong point 3? 0 na, di ba? Kanibalik naman siya sa origin. So, SC is 0 and SB is, we only get it at 327. So, ang ato na pong velocity BV squared mo is atong i-cancel kay agi 0 equate to 0. Then, 0 minus 320 and negative times negative, negative times negative, you have positive, but negative, negative, yeah. Uh, since our assumption is upward positive and our downward is negative, so our velocity is 80.1 meter per second downward. So if you are not you are not saan siya pag dili mo maka uh, maglibog mo ani, so it only means that your velocity, your VC is downward. So now determine the maximum height, nakuha na nato, and its velocity just before it hits the ground. So nata ang VC. So the negative root was chosen since the rocket is moving downward. Similarly, applied between A and C. So equations, ganing equation 12-6 also be applied at point A to C. So let's try. Okay. At point A to C, kabalutan nga our velocity A is 75 and we don't know yet the velocity at C just before it hits the ground. So, but we know that our acceleration is constant and SS is 0 but our SA is 40 from the origin. So, 0 minus 40, that's 75 squared plus 2 times negative 9.81 times negative 40. You take the square root and you'll get the same answer. So just be sure to use these equations, katong three constant acceleration equations, if it is stated or if it is implied in the problem that it has constant acceleration. Otherwise, you use the first three equations. Your v is equals to ds over dt. Your acceleration is equals to dv over dt. Or the third equation is ads is equals to vdv. That's all. And for your problem set, use your ID number. If your ID number ends with an odd number, then answer the problems in odd. Answer the problem in 12.1, 12.3, 12-3, 12-5, 12-7, and 12-9. When your ID number ends with an even number, then answer the problems in 12-2, 12-4, 12-6, 12-8, and 12-10. All your submissions will be in our Google Drive. I will post this one in our Google Drive. That's all. See you next